Okay, Corona's 100 integrals number 17. So this question is very similar to the previous question number 16. We've got a fraction here. On a denominator, you've got an x multiplied by a square root of a squared plus x squared. This question requires you to use another trig substitution again, but if you pay attention to a squared plus x squared, this time the substitution is not going to be like, sine x or cos x. What we are going to use is we're going to use 1 plus tangent square is equal to secant square to help us to do the integration. But you also need to pay attention, that's an a square here. So what we need to have is we need to have x is equal to a tangent theta. So we need to put an a in the front to sort of like, after you square it, you're going to have an a square out. And so we can factorize an a square, and that will give us like a 1 plus tangent square later on. Okay, so let's start with this. So the first step you do is you let x equals to a tangent theta. All right, so we're going to prepare our integration here by using substitution. So dx is equal to a, when you differentiate tangent theta, you get secant square theta d theta here. All right, so once you finish that, we should be able to just do the substitution now. All right, so integrate the dx now is replaced by everything here. So we're just going to copy everything down on the numerator. So a secant square theta d theta over. Now x is equal to a tangent theta, and we've got a square root a square plus a square tangent square theta. All right. So the next line of working out, what you can do is you can cancel the a and a here first, and then you can take the d theta towards the end, all right? So you don't have to put a d theta on the numerator. So you've got tangent theta here as a denominator, and what's inside the square root, okay? What happened to the square root is you've got a square, and you factorize this one out. You get 1 plus tangent square theta. And we also know that 1 plus tangent square theta is equal to secant square theta here. Okay, so in that case, what we can do is take out the square root, so that gives us tangent theta times by a and secant theta here. You still have d theta there. All right, so once you finish that, now what we can do is simplify the numerator and denominator. So that secant theta is going to cancel the secant square theta on top. What you can also do is move that a to the front, so treating this as like a coefficient. So that becomes 1 over a. All right, integrate secant theta over tangent theta d theta. All right, so once you finish that, you can use the trig identity formula to change what's inside these integrals. So we know that secant theta is 1 over cosine, so we can change that. That becomes 1 over cosine theta. Now we divide by tangent theta. All right, remember we divided by the tangent theta, but in this case we sort of need to times by the reciprocal of tangent theta, which is cotangent theta. But then that's also equal to cosine theta over sine theta. Okay, so in that case, we can actually combine two steps into one. That gives us cosine theta over sine theta here, d theta. So at the end, we get 1 over a. We can cross out the cosine theta with the cosine theta there. We'll get a 1 over cosine, which gives you cosecant theta, d theta. All right, so now once we finish this one here, then we need to know how to integrate cosecant theta d theta. Another really special integration that you need to know how to do it. All right, so cosecant theta, what we are going to do is convert that into a fraction. We're going to multiply both the numerator and denominator of the fraction by cosecant theta plus cotangent theta. It's pretty amazing if you times these two terms, and eventually you will see the integration is very nice. It can be solved very easily. Okay, so let's expand the numerator. So you get a cosecant square theta plus cosecant theta cotangent theta over cosecant theta plus cotangent theta d theta here. All right, so it's a fraction. All right, the first relation when you see a fraction integration here is thinking about the reciprocal integration, so like in terms of logarithm. Now, if you try to differentiate a cotangent theta, the derivative of cotangent theta here is equal to negative cosec square theta, which you have here. Then the derivative of cosec theta is equal to minus cosec theta and cotangent theta, which is again very similar to the numerator. So what we need to have is put in an extra negative in front of both cosec square theta and cosec theta and cotangent theta. And that's what we need to do. So what we need to do is create a negative outside and put a negative on the top. Okay, so everything is ready now, and we should be able to integrate this now. The theta, so I'm going to highlight this one for you. The derivative of cotangent theta here is equal to cosec square theta, and the derivative of cosec theta here is equal to minus cosec theta and cotangent theta. They actually just match. So therefore, the answer for that is just going to be minus 1 over a, okay, ln absolute value, and you just copy everything on the denominator, and plus c at the end. Alright, so once we finish this one, we still haven't finished the question. As you can see, it's in terms of theta here. So what we need to do is we need to remove the theta and change that in terms of x, because that's the part of the question, right? The question tells you it's in terms of x. So we need to change those two theta here in terms of x. All right, so what we are going to do is, again, using a triangle. Previously, we actually let x equals to tangent theta here. So therefore, we know, we let x equal to a tangent theta. So we know that x over a is equal to tangent theta. All right, so we can use our right angle triangle again, like the previous question. So the opposite of adjacent. All right, and the hypotenuse is just equal to a squared plus x squared, square root. Okay, so from here, we should be able to write down our answer. That becomes 1 over a ln absolute value. Now cosec theta, cosec is 1 over sine, which is, hypotenuse, okay, over adjacent. Okay, hypotenuse over adjacent. So that gives you square root of a squared plus x squared over x plus, now cotangent, which is reciprocal of tangent. The tangent is x on a, so cotangent is just reverse process, right? So that's reciprocal a on x. So that gives you a on x, absolute value, plus c. Okay, so that's it. It's a pretty tough question there. Now, as you can see here, we need to start with, we need to realize this is a trig substitution. Once you finish that, you need to be able to simplify it. And even towards the end, you are dealing with a pretty hard integration in terms of sector theta, which you're using a very special way by multiplying both the top and the bottom by sector theta plus cotangent theta. And then towards the end, you still have to do another substitution to work out the answer. So that question is pretty tough. Okay, thanks. All right, thanks for watching.